Hello and a very good afternoon, everyone. I think this is now time for us to start our today's discussion and session about so our today's topic is how to optimize cloud expenditure and maintain well-architected best practices in AWS. So we have two amazing professionals from two different companies. One we have with us today Mr. Rishabh Yadav. He's a partner solution architect working with the emerging partners from team at AWS. So he has been working with Asian partners to provide guidance on enterprise cloud adoption and architecture reviews. Along with that, he also is building AWS different practices for their partners or their client solutions and implementation of well-architected framework. So outside his work, he likes to spend his time in sports field. So hoping we would have a very good interactive session with Rishabh. Along with Rishabh, we have with us Mr. Raisul Islam from BrainStation 23. He's one of the SBU lead in BrainStation 23 who is looking after European market. So uh, Raisul Bhai would be covering the well architect best practices that we follow in BrainStation 23 and which is the best practices followed by the global industry as well. So hoping for a very enlightened session and feel free to ask questions and do interact with the professionals. I'm hoping that you would get your all your answers accordingly. Thank you so much. All the very best. Over to you, Rishabh.
Yeah,
You're on mute,
thank you.
Rishabh. Yeah.
Yeah, thank you. Can you hear me?
Yes, we can hear you.
Okay, perfect. So thank you for the lovely introduction. And thank you everyone for joining in today. Eh, Thank you everyone for joining in today. So my name is Rishabh. I'm a partner solutions architect in AWS. And it's good to be, presenting after a long time. So before we get started, let me also provide a quick introduction about myself. So most of which is already covered by the presentation team. So my name is Rishabh. I'm a partner solutions architect working with AWS, and I've been working with AWS for close to 4 years now. And prior to owning the partner solutions architect hat, I used to work as an AWS cloud architect and AWS cloud engineer. My background basically comes from microservice architecture. And in today's session, we'll be covering topics more on the scale of how to optimize cloud expenditure on AWS. And in between, we'll be looking at different metrics and different ways through which how I mean, I think there's some disturbance coming in between. Can you please unmute? Can you please mute your mics? Yep, perfect. So, today we'll be covering on how to optimize cloud expenditure in AWS. And in between, please feel free to ask any questions, or you can also wait till the end of the session. And with that, let's get started. So let me just go off camera to save some bandwidth. And can you confirm if my screen is visible?
Yeah, your screen is here.
Thank you. Thank you very much. Okay. So when we talk about cost optimization, right? So cost optimization is one of the pillars of AWS well-architected framework. And this framework is something that we suggest to our all customers, ranging from emerging partners, SMBs to big enterprises, that they should build their architecture based on AWS well-architected best practices. And this is where cost optimization comes. And today we'll only be covering this one pillar. So I'd like to start with one of the quotes of our CTO, Mr. Werner Vogels. So when we talk about driving cost down or cost optimization for our customer, it's one of the key parts of Amazon culture and a big part of our customer obsession. And when you talk about cost optimization, it's not something that you just look at the AWS bill. It's basically more about how you can measure and understand the value that your resources and workload are providing to your business. So, for example, a workload is not considered to be cost optimized if it has very low bill but does not generate any revenue to the business. And that's why today technology exists to basically serve the needs of the business, whereas cost optimization exists to do this as efficiently as possible. So coming on the same part, like cost optimization is not just talking about dollars and cents. Optimizing your cost on AWS can allow you to basically do more for less. So it's more than just cost savings. Basically, if you apply the proper cost optimization techniques, you can allow your organization to be more agile to meet your customers' demands. And you can use those same savings to invest back in your organization to innovate faster. And seeing the today's world where things are changing at a rapid pace, this becomes a must. So going forward, I'll be diving deeper into some of the cost optimization design principles that we use. So we basically have 5 design principles. First one is to practice cloud financial management, adopting a consumption-based model on AWS, how to measure the overall efficiency, how to stop yourself from spending on undifferentiated heavy lifting, where you are managing the entire infrastructure. And last one is to analyze and optimize expenditure. So let's think about how we would approach cost optimization in a traditional on-premises environment. Let's say where there's no cloud. So in this case, you basically have to invest your capital expenditure or what we call as capex for new infrastructure before you need it. And most of the companies, they're not large enough to benefit from these economies of scale. And that's why they have to spend more time and money on the undifferentiated heavy lifting. For example, maintaining, stacking, and racking of data centers. Additionally, since when we talk up from a on-premises traditional data center point of view, there's only centralized cost that we can check. There's no way, to map cost to individual teams or individual projects. So it becomes quite difficult to understand, like, from where are we getting so much higher cost and what's the impact of that cost onto the revenue of the business. And last one is that since we by default purchase a lot of servers, they most of the time they run at a lower utilization since it is hard to share between the resources. So this is where cloud comes into picture to remove some of these constraints. So with AWS, you only pay for computing resources as you consume them. Additionally, AWS does the heavy lifting of managing the physical hardware and data. Whatever you have to do in a traditional data center, that underlying lifting is done by AWS. And now you can also utilize managed services to have a lower cost and eliminate the time and cost of managing servers. So going forward, we'll be looking in deeper into what exactly does this design principle mean and how we can optimize the cost in our existing infrastructure. So the first part is to have a cloud financial management capability into our team. So this basically means that we should invest our time in creating a team which is responsible for maintaining and establishing cost awareness across the organization. So this team should include people from business team, dev team, finance team, so that they understand the different aspects of how costs are getting calculated, how your TCO works on a higher basis. And this team should be responsible to implement cost awareness into new and existing processes. So what I mean by this is we should basically focus more on improving our planning process. So first one is to implement the cost planning best practices, which means what kind of KPIs are you currently defining? How are you calculating the cost of a specific project starting from the planning phase? Additionally, do you have specific tagging in place so that you can restrict the cost or you can map the cost along with individual projects or not. For example, let's say if I have a project running from dev team A, and if I have specific tags for that, I know that what is the consumption of dev team A. Same way, I can basically isolate cost for multiple teams using proper tagging and cost categories. And to achieve cost planning best practices, AWS budgets is something that is widely used all across the industry as an industry standard. So for different teams in your AWS console, you can set budget thresholds. So let's say for dev team A, you can set a monthly threshold of $1,000 USD. And in case their utilization increases or goes above that threshold, automatic notifications or alarms are getting created to notify you that yes, you have currently exceeded your monthly quota. And same way, these metrics can be monitored on a specified AWS budget dashboard so that you can do more deep dive into where are you spending your cost. Next one is adopting a consumption-based model. So one of the most important part of cost optimization is that you should not pre-default, try to judge your capacity. You should only pay for computing resources that you require or resources that increase or decrease in usage depending on your business requirement. So this way we can eliminate the forecasting part that we'll be requiring X number of resources in future. What you do is you just look at the current metrics, you look at your current traffic, and based on that, uh, you adopt a consumption-based model. So on my screen, you can see an example. So cost should always be associated with usage and it should never be flat. So flat cost, they basically result, in period of underutilization, which are missed opportunity where you can significantly increase your savings. So if you see on the screen, uh, what is marked with the green line is the cost. And if you see our cost is flat, even if our usage is increasing or decreasing. So this is a bad setup for cost optimization because here there's no direct parameter which is mapping cost with the usage part. So this is a more optimized version. If you see our cost and usage, they are somewhat aligned as compared to the previous one. So that's what I'm talking about, like the cloud pay as you go model coupled with the speed of provisioning resources, it makes it quite easier to optimize workloads. And here costs are directly influenced by usage. So you should always go with the pay as you go model. And this is the best usage where you have a direct mapping with cost and what is the usage of your business. Similarly, some of the best practices that I'd like to share is let's consider our infra on the left hand side. So this is a normal example that I've taken. So on the left hand side, we have two environments. We have a pod environment and we have a dev and test environment. So if you see, there are certain resources which are running in dev and prod environment. And both these resources are running 24 hours for 365 days in a year. And considering $1 per hour as an instance cost, it costs us approximately $17,500 in a year. So this is a setup which is not currently optimized. Because the thing is that we should always shut down, suspend, or terminate resources which are not in use. So this basically means that production environments are usually required to run 24 hours a day all year long. However, when we talk about dev and test environments, they are usually used only during working or business hours. So this means that 8 hours in a day on the weekdays. So that's why on the right hand side, if you'll see our production servers, they are running 24 into 365. However, after doing a proper TCO planning and a cost optimization, we have reduced our dev test workloads to run 8 hours in a day only on weekends. That is only on weekdays. That is 261 days. So you can see that our cost has decreased from $17,500 to $10,800, and that's approximately 50 to 60% cost savings directly. So to summarize that, shutting down dev test environment outside of the usual work hours, it can help with a lot of savings. Do you have any questions till now? Or we can also go ahead and take the questions at the end. Okay, let's proceed ahead. So the next design principle that should be taken into mind while developing your system for cost optimization is how to measure the overall efficiency. So what I mean by efficiency is that how you should look at the complete picture. Yes. So how to look at the complete picture when we're talking about, cost, when you're looking at cost. So this is a comparison between cost versus investment. So the main thing is that it's important to understand what's the reason for an increase in cost as well as the result it had on the business. You should not just think that the increase or decrease in the dollar value. You should think how your business is getting affected with that. So a CFO might, let's say, consider a CFO, a Chief Financial Officer. He might be concerned with the increase in their monthly expenses. However, if that result in a positive impact to the business, it is not longer considered as a cost to the business, but is basically more looked at from the point of view that it's an investment because your revenue has directly increased. So this has to be measured with business KPIs such as increase in your orders, revenues, customer usage demand, etc. So on the screen, if you see on the left-hand side, the CFO is worried that the monthly expense has gone up by 15%. Then what is their team doing? That why is the expense are going upwards? On the right-hand side, if you look it from a different perspective, you can see that after optimizing the setups, the overall number of orders have increased by 35. So this is what I was getting at. That if your business is getting increased with the increase in cost, it should be considered more than an investment. That's why there's no hard and fast rule to directly determine how cost is getting impacted. You should make a side-by-side comparison with the revenue impact. So if you had a cost visualization dashboard, this is very easy to understand. So you can notice the increase in cost after a change in the workload. So this is a concern for most of the CTOs and finance teams. However, if you see that if we overlay these changes in revenue, it is apparent that the significant increase in revenue as well. The cost can be directly mapped to the revenue. So this is basically a return on investment. And this is the value proposition that should be looked at instead of the cost and revenue metrics. The next design principle is how to stop spending money on undifferentiated heavy lifting. And this is one of the most important points that most of the organizations or most of the developers, they initially overlook. So as you already know that AWS does the heavy lifting of data center operations, like racking, stacking, powering the servers. And it also removes the operation burden of managing the systems and applications with their managed offerings. So at AWS, we have multiple managed offerings where you are not required to do anything and where you can just simply focus on building your application, whereas we handle the underlying provisioning and managing part. So this basically allows you to focus on your customers and business project rather on the IT infrastructure, where most of the time is getting wasted. So if you see on the screen, I've taken an example. So, leveraging managed services will greatly reduce your operation burden. That's one thing. And it also allows your teams to focus on the business needs instead of getting bogged down by routine, mundane tasks. On the left-hand side, you can see an engineer who's asking like, how can we improve our deployments? But your team is not able to, look at these issues because they're more uh, involved or bogged down into patching the underlying instances. However, If we just directly move this infrastructure from a normal EC2 instance with load balancer and a unmanaged database to Lambda or to a more serverless infrastructure, we have DynamoDB, IDS, AWS Lambda API Gateway. You can see that most of the time that your team was initially spending on mundane tasks, they can now focus on actually developing the code or actually developing the application. And this is something that is also part of the complete TCO. So usually people don't understand, like, under TCO cost is not, the direct cost does not have that much impact, but we should also look at the tasks which lead to productivity, and at the end they also lead to how your costs are getting calculated. Because if you consider an important engineer, let's say, if the majority of the day is getting wasted in managing the underlying infrastructure, you're wasting some money on that part. Instead, if you move to a managed offering, you can save that cost, and that engineer can have an increased efficiency in developing the application or the system. So let's move ahead. Let me provide it a more structural view to what I was trying to say. So if you host your databases in Amazon EC2, on the left hand side, you can see like what all the resources for which you are responsible to maintain. So everything starting from app optimization, scaling, high availability, backing up your databases. That's one of the major challenges. If you ask any person who worked with the databases, even all the people who are in deep as a who work as a DBA, database backups are one of the challenges. Most of the time are getting spent there. Additionally, what if your system goes down in one availability zone? Then you have to again restore everything back from the backups into another region, which is another pain. Similarly, continuous patching the databases, installing latest hardware updates, OS patches. For all of this part, your team will spend 70 to 80% of their time, working on managing the underlying infra. However, for this example is only valid for EC2s. On the right hand side, you can see Amazon is responsible for only maintaining the OS installation, the server maintenance, rack and stack, and the powering up of the data center instances. However, with just a quick change, so if you decide to move from an unmanaged service to a managed service, let's say Amazon IDS, you can see the changes over time. So now, on the left hand side, you are only responsible for for your application optimization. Whereas on the right hand side, for everything other than application optimization, that is scaling, high availability, database backups, AWS is responsible to handle all of that. So that frees up a lot of time. And few of the examples of this are when we move to IDS, for example, in this specific scenario, we already have automated backups. Backups are taken every hour. We also have point in time recovery. Let's say if you want to restore your database to a particular point in time, let's say 10 minutes ago, 20 minutes ago, 1.5 hours ago, that can be easily done with a single click. The patches are already handled by the AWS team and they are rolled out in a maintenance window that you can choose. Same goes with the high availability. With a simple click, you can set up a multi-AZ database. And if database in a availability zone 1, it goes down, AWS will automatically transfer your existing database connections to the multiple AZ copy into another AZ, and your application won't be affected with that. So this way, first thing is you are freeing up your engineers' time on these mundane patching tasks. Another thing is that your business is not getting impacted. So you're getting cost benefit on from both the ends. Let's move on to the next one, how to analyze and optimize expenditure. So this is the last design principle and one of the most important ones. Just a minute. Yeah. So when we talk about the cloud, even though the cloud makes it easier to accurately identify the usage and cost of any system, it also allows for the transparent attribution of IT cost. Like, for example, what team owns this particular server? with this particular project, and what's the amount of cost that they're contributing, and what's the revenue impact. So you can easily measure your return on investment for given workloads. So this is something that we initially covered. So when we identify our usage and cost pattern and implement the AWS cost optimization design principles, you'll notice that the learnings from one team, using the learnings from one team, the other team also gets benefited from that. So if you see, for example, when multiple teams are working or are involved in a project, ensure you are able to precisely identify what a team is responsible for, what particular resource should a particular team be responsible for, and work with those specific stakeholders on optimizing their spend. So if you see, the CFO can now take learnings from team two. On the screen, you can see a team two on the right hand side and share the knowledge with the other teams to optimize the cost. So the team one, they were no. If you see the team one, they were normally working with AWS with on-demand instances, and they had a higher monthly bill. However, team two, they also tried to optimize their workloads and they purchased a savings plan. So savings plan is basically you commit to a specific usage of your resources, and based on that, you can get up to 70% of discounts into your daily running workloads. It's basically like a reserved instance. However, here you don't have to do any 1 year or 3 year long term commitment. So another important aspect into optimize and saving cost is how you should take control of cost and continuously optimize your spend. So first thing under this is pricing models. You should be aware of like what are the different types of pricing models which are available, and which of these pricing models suits your use case. So AWS offers services through multiple pricing models. So some customers can buy the same instance using on demand, that is pay as you go prices, or some users they can purchase, they can commit to a 1 or 3 year long contract, and they can receive discounts up to 70%. Additionally, some users they can purchase preemptible instances. These are basically instances which can be terminated at any time at a much lower price. So spot instances can provide up to 90% of cost saving as compared to on-demand pricing. The only issue here is that these instances can be terminated anytime since they work on a bidding process. So if any other user bid a higher value as compared to your bid, so the instance maybe get terminated in 2 minutes and it will be get assigned to the highest bidder. Second thing is matching capacity with demand. So, so AWS provides many services that helps you reduce cost by aligning resource to usage and capacity. For example, we have a service called AWS Instance Scheduler, which can help you to automatically terminate idle Amazon EC2 and IDS instances. So you can automatically use that to set up automation. And if it sees that if your instances are idle for any particular duration of time, it will, dynamically or automatically stop them, thus providing you further value for your bucks. Additionally, for any increasing and decreasing or a dynamic workload, you can always use EC2 auto scaling to improve your application's availability and control cost. For example, let's say if your application in high traffic, it needs to be run on 6 instances. But on a lower traffic day, it needs to run on 2 instances. So you can create an auto scaling group, set a minimum capacity to 2 instances, maximum to 6. And based on your load demands, you can set a metric. So if your CPU utilization increases from 70 to 80%, you can scale one instance. You can add one more instance to handle that load. So this way you can also ensure higher availability and also keep a check on your costs. The last field under optimize and save is how to simplify and optimize resource selection. So, in this case, AWS Trusted Advisor is something that we recommend. So Trusted Advisor basically helps you to inspect your environment and identify the underutilized resources. So if you go into the Trusted Advisor in your AWS console, you can see that it provides some cost saving recommendations. Like 3 of your instances are currently underutilized, they're running on 25% of utilization. You can save much more value by moving this instance from, from a larger instance type to a smaller instance type. So these type of recommendations are provided by trusted advisor. Same goes with compute optimizer. Let's say if you're not sure about which instance type to choose, so you can directly input your workloads like how many vCPUs, how many GPUs or memory do you need. And the compute optimizer, it will automatically provide you suggestions like this is the best instance based on your use case. And it is also one of the cheapest one that can serve your use case without any issues. So this is what that we talked in the previous slide, selecting the right purchase model. So if you have a workload which is a steady state workload, so you know that this workload will be running continuously for at least 1 or 3 years, and you have a committed usage. For that, I would suggest that you should go ahead with reserved instances. So if you go into a 1 or 3 year commitment plan for your steady state workloads, you can get up to 75, 72% off on EC2 RDS and other services. So this way you're simply saving a lot. It's just that you just have to identify your workload and map it to what instance type should be better for that or what model should be better. Second one is savings plan. So savings plan is similar to reserved instances. Here, the only thing is that it provides you more flexibility. So you don't have to go into a 1 or 3 year commitment. I mean, you do have to go into a 1 or 3 year commitment, but you don't. You can measure your usage in dollar per hour. So let's say if you can commit to, I'll be running my workloads for 8 hours a day in a 8 hours a day. Then you can go ahead with savings plan and you can get more flexibility into the discounts. And the third one is easy to spot instances. So if you have any workloads which are fault tolerant, for example, let's say every day you have to run some batch processing workloads, or you have to process some logs, which is a task that can be interrupted but needs to be done in a day, in a 24-hour window. So for those, using EC2 spot instances is a great deal. So you can simply save up to 90% of the cost as compared to on-demand prices. So the best practices for cost optimization is that you should combine EC2 purchase models and you should basically do a mix and match of these models. So if you see on the right hand side, you can see from the purple, there's a RIs or savings plan. So you divide your workloads into steady state, run those workloads on reserved instances. Then for any workloads where you're not sure about the kind of traffic that you will expect, or is an application where you can't predict its behavior. So for that, go with on-demand instances for stateful workloads. And for any workloads which are stateless that can be interrupted in between, but can be completed, they have a flexible, a flexible SLA for completion. For that, you should go ahead with spot instances. And including this, combining this with EC2 auto scaling will not only provide you higher cost saving, but also will provide you higher availability. And so on the screen, you can see that some of the live examples of customers which are optimizing their AWS spend by following the best practices that are previously covered. So if you see while migrating to the cloud, Tiger Spike, they were able to reduce their cost as compared to the on-prem infrastructure. And what they did was they were able to utilize AWS Cost Explorer to, to more on a granular basis, they're able to monitor their forecasted cost. What is their current cost? And based on their current consumption, what is their forecasted cost? And based on that, they were able to, create AWS budget workflows, etc. Similarly, same thing goes with Fred Hutch. So Fred Hutch, it's basically the deal with cancer research. So Fred Hutch, they increased their access to compute by using spot instances. So they had a lot of workloads which needs to be run every day, but they were completely stateless. So they can be run any amount of time, even if they get terminated. And they were able to accelerate their time to insight for cancer research using spot instances. And the last one is Nubank. So Nubank used the compute optimization service that we discussed in the previous slides, and they were able to make more informed decisions how to balance performance and cost when making updates to instance type in their fleets. So that's all from my end. Thank you for sticking till the end, and I'd love to take up any questions that you may have.
Thank you, Rishabh. It was a very wonderful session. I actually learned a lot regarding the deep dive and all. Please, anyone, if have any question, feel free to raise your hand and ask right away. Yeah, I think there is a question.
Okay, so I can see the chat. What about AWS Graviton? Yeah, so AWS Graviton is also an improved offering. So do you have any specific things like, do you have any questions related to Graviton, like where to use Graviton? Anjan.
So I think probably people doesn't know much about Graviton. I think you can address Graviton usage as per the case to case basis. So just give us two three examples, Rishabh. I think that would definitely help us to understand what Graviton is doing. Yeah.
Sure. So Graviton, basically, it's a more improved hardware, which is basically launched by AWS, and they deliver a major leap in performance and capability as compared to previous generation of instances. So if you want higher performance, okay. So all these learnings that I shared, these are not instance specific. So they apply to Graviton as well. So if you go to, let's say, any of the tools that I discussed, like Compute Optimizer. So if you input your workload based on that, let's say I have a 16 vCPU usage, I want to run these instances, let's say for this amount of time, this much memory I need, if you have any other considerations. Then based on that, it will provide you suggestions, and that may or may not have a different instance types. So whatever I mentioned previously, they are basically available for all instance types. It's not limited to a specific instance type. We usually don't have, and if you, let's say, if you have a specific workload that needs to be run on Graviton instances, then what I'll suggest is always go with the latest version of the instance family which is available. So if I remember correctly, in this year's reInvent, we launched Graviton 2 based processors, and all the instances are based on that. So the thing with this is that whenever you go with the latest instance family, it basically has a higher improved performance because the AWS development team, they're continuously working on improving the performance as well as decreasing the cost. So if you consider majority of the time, the latest instance family will have the highest in-class performance, and it will have the lowest price when you compare with the type of performance you're getting out of it. I
Mhm.
hope that answers your question.
Thank you so much. I That answers a lot of my question. So Saleh Bhai raised the hand. Saleh Bhai, do
Yes,
you have any question, please?
yes, I do. So in the cost optimization comparison slide, you have shown that the staging or testing environments can be said to run only on working days or hours to reduce the cost. That is one aspect. And you also talked about the choosing the right purchase mode, like choosing reserve
Yes.
instances, setting automatic schedulers and auto scaling, and also try using AWS trusted advisor recommendations. So those are the things that you have talked about. So now from the application optimization and AWS in infra perspective, what others can be done to optimize the cost? Like you have the production environments in place, and you don't have that scope that you try and experiment with different instance type, right? So what can be
Yeah.
done to run those production environments smoothly without trying those things? If you have some words on this, yes, that's my question.
Okay. Yeah. So I'll say that whenever you're, planning, you're doing the planning process for your production workloads as well. I'll suggest that initially you may already know like what is the workload looks like for your application. So if you know that part, just go to Compute Optimizer, put your insights like what is the production workload that you're looking at, and based on that, use the recommendations which is provided by that. So that's the first step that we suggest, because Compute Optimizer internally, it uses its own machine learning models, and based on your inputted workloads, it's tried to determine the best performance versus value combination. That's one thing. Second thing is, yes, I know that sometimes it can be, difficult to identify, like, forecast your workloads, like how much workload will the application be expecting in future. So is it worth, going to a reserved instance approach where I have to go into a 1 or 3 year commitment? So a lot of our customers had the same issue. So that's why AWS came up with a savings plan approach. So savings plan is something like for your production workloads, I'm sure that you can commit to at least 10 to 12 hours that the instance will be running. If you can commit to that particular time zone, you can go ahead with savings plan, and you can get all the cost saving and flexibility of reserved instances. Additionally, it doesn't imply that if you buy a savings plan for one instance type, then it cannot be used for other instance type. So let's say if your use case, let's say if your use case or your it's already done with the first instance, then you can move the existing savings plan and use its features on another instance type. So it's quite flexible that way. And third thing is that you should include auto scaling with this. So if you see on auto scaling, you can implement a combination of on demand plus spot instances as well. So let's say you have a workload where you have some major servers which will be running every day. So you run, for example, I'm taking just an example here. So you run 2 instances on demand, or let's say 2 instances on reserved instance patch. So this will be instances which will be serving your important application, which cannot face any downtime. However, for any fluctuating workloads, you can specify a combination there that I want 60% of the on-demand instances and 40% of the spot instances. So now you can run your fluctuating workloads on top of spot instances and get up to 90% of savings as well. So this will also ensure you higher availability. So auto scaling can monitor your CPU utilization, and based on that, it can launch or terminate instances, idle instances. Does it answer your question?
Yeah. But I have a supplementary question. Like one
Sure,
pain
sure.
point that I faced for one of the businesses, like uh, data transfer is a pain point for the businesses that
Yes.
has a lot of like operations going on, and like for e-commerce applications, they do need transfer a lot of data, and it is a pain point. It generates almost equal bill for the EC2 instances generate. So how do we address that? Like data transfer is huge, and AWS charges for the data transfer cost, right? So
Yes.
yeah. So how do you
So,
address that?
yeah, understand that completely. So, with data transfer charges, the thing is that if you transfer the data within the same availability zone, there are no charges. So, you should look at building your workloads on that front. I know that it's not entirely possible, but you should keep that into mind. That's one point. Second thing is that let's say whenever your application, let's say when you which is running on EC2s, let's say they might be making some calls to internal AWS services, let's say S3, RDS, anything. So if you use a normal NAT gateway or the internet gateway to route this request, they're going to come under your data transfer output bills. So what you should do is you should try to optimize. You must have heard about VPC endpoints, right?
Yeah.
Yeah. So what you can do is any of the AWS service which is available, they already have an internal endpoint via VPC endpoints. So what you can do is you can directly create a VPC endpoint connection with that service, and any traffic, it will go through that endpoint and it will never leave the AWS internal ecosystem. So, and the major advantage with VPC endpoints is that they are up to 40% or 50% cheaper than NAT gateways. So this will, basically slash down your data transfer cost to half.
Okay. Okay. Thank you.
Any other
Got it.
question? Okay, great. I think Rafid Bhai has been raising his hand for
Uh,
a very, very long time now. Yeah.
yeah, I had a small question. So at the beginning, you mentioned that uh, turning off dev or test environments could reduce the cost. So what would be your preferred method to, let's say, turn off and turn on an instance? And instance could be, let's say, an EC2 and EKS environment. So what would be your preferred method, or what procedure would you follow to, let's say, take down the environment and bring it up again seamlessly or automatically?
Sure, sure. So, yeah. So when we talk about, closing down or scaling down your dev instances, let's say on weekend, if you don't need it, then it doesn't mean that you have to terminate your complete, let's say EKS cluster environment or ECS cluster, or you don't have to create again from scratch. What I mean by that is, whenever you create your workloads, create them using a auto scaling picture into mind. That they should have some kind of auto scaling enabled with them. You can simply change the desired capacity to zero in your auto scaling groups. So even if you work with EKS, we now have EKS autoscaler, pod autoscaler. Similarly, if we talk about ECS, we have application autoscaling or service level autoscaling. In normal EC2s, we have normal autoscaling, where you can simply set the desired count to zero. And what it will do is your environment will keep stay as it is, only is that the number of instances will scale down to zero. Another thing is that most of the services, they already have, you know, uh, integration with instance scheduler. So instance scheduler, I know that currently it basically works with EC2 instances and IDS instances. So with EC2 instance scheduler, what you can do is you can configure instance scheduler, and based on that, if it will, I mean, if it will see that any of the instances are idle, it will automatically terminate them. So these are two approach: auto scaling, I mean, setting the desired capacity as zero on auto scaling, so you don't have to terminate your entire infrastructure. And second one is to use instance scheduler.
Yes, that answers a lot of my queries. Thanks a lot.
Welcome.
Okay, great.
Any
Any
other
more
queries?
question? Any other question for Rishabh on the cost optimization part? No, I think we can then move on to the next segment. Thank you so much, Rishabh. That was a really wonderful session, and it was interactive as well. Really great to have you with us. I think we can start with our next track, which is on how to maintain the well-architected best practices. And we have with us to present on that Raisul Islam Bhai from Rain Station 23. Raisul Bhai, please, the
Thank you.
mic is all yours. Yeah.
Hello. Sorry. Um, can you hear me clearly?
Yes, Bhaiya, we can hear you properly.
Okay. So, hello everyone. So, my name is Raisul Islam. Let me share my screen with you as well. Mm, mm, mm. Can you see my screen?
Yes, Bhaiya.
Okay. Um, so, my name is Raisul Islam. I have been working in Grain Station as a strategic business unit head for last 1 years, and before that, I have been working as a solution architect for a few years. And from today, I will be discussing on cost optimization framework, cost optimization pillar of the AWS Architect framework, how AWS Architect framework, well architect framework can help to optimize the cost. So let me start. And first of all, thanks to Rishabh to make my job easier. So he really did explain very well in the design pattern principles and other stuff. So let me start with the first. Just give me one time to stop my camera to save some bandwidth. Okay. So let us start with the software development life cycle first. So how we build an application. So basically we have started with the planning phase of every software development, and we do plan for the application features, budgeting and architecture, and then we do the analysis of SRS, and we design the UI, building prototype, and finally we started development, and after completing the development, after doing the UAT, we finally launched the product in production. So these are the very fundamental and general steps of building an application, right? But there is one thing I think in software development lifecycle, we are not talking about like in which steps or where we should consider the architectures or architectural part. And the next question comes after this is like the system we have developed, is it well architected? So how do we say that? And the most important thing is like system architecture should be an ongoing process and it must evolve, and architecture is an essential part of every step, right? So we cannot ignore it. So initially we may thought about the architecture, but later on it must be evolve. And if an application is well architected, then it must have these following characteristics. Like application needs to be functional, it needs to be robust, it must be measurable and debuggable. The architecture should be maintainable and reusable, and at the end, it needs to be scalable. And all of this, I think, comes like a general concept, the basic concept of software development lifecycle. And then comes the well-architected framework. So all of these that we have mentioned, the characteristics of a well-architected application, how we are gonna say like our application is well-architected. So sometimes we can say maybe or maybe not, but I think that's not the right answer. So to define whether it is a well-architected or not, we must follow some kind of like framework or a structure. And AWS Well-Architected Framework is a well-defined framework for cloud architects, which helps us to build secure, high-performing, resilient, and efficient infrastructure. This framework is based on these 6 pillars. So initially it was 5. Recently, AWS introduced the sixth one, the sustainability. And each of these framework has its own area of focus and design principles. But today we are going to talk about the cost optimization. And the cost optimization pillar mostly focus on avoiding the unnecessary cost of the organization by using its best practices and design principles. And if an organization can like adopt this cost optimization pillar, then that organization can achieve the things that Rishabh described very well in earlier presentation, that cloud financial management, the awareness of the cost and the expenditure, and we can use cost effective resources, and we can always have a focus and control over demand and supply, and this needs to be optimized over time. So I will not like spend much time in this portion since it's already defined very well. So it's just some common slides. These are the design principles that has been already well defined and described. So these are the focus areas. This has also been covered. So I'm going in a very high level. So the cost optimization focus areas like cost effective resources. So as Rishabh mentioned, that we can use the appropriate sizing and appropriate purchase option to minimize the cost where it is necessary. And also we can match the demand and supply, and we can optimize our resources and utilization. And also the expenditure awareness is very critical and important, and this needs to be optimized over time. So this part is very critical for this architect framework. Like we have to measure, monitor, review, and improve. So this is like a cyclic way. So this is the cost optimization life cycle mainly we want to follow. It's like a ongoing and regular process. So first we need to find the uses and cost of money and monitoring, and then we need to do the analysis where the cost has been spent and how the cost has been occurring, whether it is needed or not. So all kind of analysis needs to be done, and then we need to define the action points, how we are going to optimize the cost, and later on we do the cost optimization, and finally we need to like make this cost optimization as a part of cloud financial management of your organization. So that's like a cyclic process. And today I'll be mainly focusing with this tool, and we will give you some real example that we have been worked recently. This tool is like Well-Architected tool, and it is you can easily find it in AWS console by searching like Well-Architected tool. And in the Well-Architected tool, we have these all 6 pillars defined there, and under the 6 pillars we have some set of questionnaires there. And basically this tool is very useful for us to identify the high risk issues, and we can define whether what is our status and how we are going to improve those things. So all of these has been guidelined in this architect tool. So mainly how it works. So first of all, we started with the review process of an organization or of a workload of some application. So initially we started the review process with this architect tool, and we do the review, and we put answers of those questionnaires, set of questionnaires on every section. And after getting those answers from the client side, or maybe by like do some checking on the infrastructure level, we find some high risk issues and medium risk issues as well in our architect tool. And based on that, AWS shows some recommendation as well, like how we should mitigate or remediate those things to make it like a well architect. And then we go for the remediation. So based on the high risk issues that we have identified in the workload, we started working with the remediation. And remediation process is like we defined which is important and which is must. So we started with those high risk issues very first, and after solving those high risk issues, we go for the next high risk issues or medium level issues. And after completing those high risk issues and solving those high risk issues, we started again the monitor and optimize. So it's like a cyclic process, so we can do this in very frequent manner. And let me give you a few examples from our experience recently. So recently we did a review process for one of our European client. uh, 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 I'll not say the name of the client, but it's like due to NDA and a GDPR issue. So just give an example, we do the well architect review of that client, and we find few high risk issues in every places. So in the cost optimization part, basically we had like a few issues identified as a high risk issues, and we discussed this with our client and help our client to like started with the cloud governance or financial management system. Basically they did not have that earlier stage, and that's the concept most of the client are not aware of. So first we create the awareness to our client that we need to build a cloud financial management, and it's very important for your organization to govern everything. And we need to know the forecasting and expenses and budget everything. So we discussed clearly on that part. And then we after identifying the high risk issues, we started to solve that. And finally, I can say the amount that we have saved. In general, the client had a bill in every month like 10,000 plus USD. on an average. And then we used like reserve instance in some cases for RDS and S3 instance, and we asked them to use some like CloudFront distribution rather using the S3 directly. So we saved almost like 6,000 USD per month. So currently they are having bills per month like 4,000 something USD. So that's one case we have optimized. And there is another case. We did the same thing for one of our local clients as well. And that local client had a bill almost like 5,000, 6,000 USD. And that client was using like various kind of services, EC2 and the serverless API gateway and Lambda, DynamoDB. And in that case, basically, we have to do the optimization in two parts, one in the application level as well as in the infrastructure level. So in the application level, we found something like they are not using the DynamoDB in the right way. So we give the recommendation. And also in the application infrastructure level, we improve few things by using like the reserve instance for RDS and S3 instances. And in some cases we use the cloud from CDN. And there is another thing, I think region is also very important. Like it can also save some cost if you choose the region appropriately. So region to region the cost is varying. So based on this, like we save there almost $3,000 per month for that client. So these are a few examples from our side. And I think there is two things you can going forward you can just follow. Like this well architect tool is very easy to use, so it can be used by anyone. So if you want, you can try it yourself as well. And there is one thing we can also, as a partner cloud well architect partner, we can also help you to identify those high risk issues. And in some cases, if the workload is very complicated and critical, we can also ask help from our AWS partner architect. So that's like a shared responsibility that we have with our clients. So uh, it's basically helping our in clients to cost optimize the cost and like use the right resource with the right amount of money. So that's our goal. So thank you. So I think if you have any question, we can take it.
Yeah, any question? Anyone? I think there are no questions. So well architect framework review, it's pretty standard process that any good partners follow whenever they're building their applications, or any good users follow. So we recently got we got this competency as well architect partner reviewer from AWS. So we are now the advanced partner, and we are doing architect review with this competency achievement, and we are offering this well architect review for free. So since we see a lot of participants from different organizations have joined in the discussion today, feel free to get back to us if you want to do the review together. We'll be more than happy. Our technical team will be more than happy to help you. And with that, I would like to thank all over again Raisul Bhai. Thank you for your amazing presentation. And Rishabh, obviously, he has done his part really well. So anyone, do you have any feedback regarding regarding to this session? Do you want to continue this kind of session in the coming days as well? Just feel free to unmute your microphone and let us know what is your thought around this kind of discussion. Anyone want to share? So Irfan Bhai is writing that thank you very much, learned a lot. It was an amazing session. Thank you for arranging. Okay, you are welcome, Bhaiya. We are more than happy to organize. Anyone else? Okay, we will do that. We will keep arranging this kind of session. I'm sure, like, people learned a lot today, but there are more things uh, that goes parallelly with knowledge sharing, right? You have to practice in your like real life. So that is something we can help you if you are already running your company workloads on AWS. We can help you with the cost optimization part and the uh, review part as well. Feel free to just drop us an email. I think you already have my email. Feel free to drop us an email and we'll arrange everything accordingly. So if there is no more question, then I think this is time we say a very good day to everyone. That you have a wonderful day and weekend ahead. And thank you, Rishabh and Raisul, once again for for being our speaker for the session. Yeah, thank you so much, everyone. Have a great day. Bye bye.
Thank you, everyone. Bye.
Thank you.
Bye bye.
Bye.